All right, so this Friday, May 8th, is just the introduction to what you are going to be doing. There's 3 steps. Each step is right now you're watching this Edpuzzle. So that's how I know that you actually were introduced to the project. So please make sure you watch the video in its entirety. I'll put some questions in there and some stuff just to kind of make sure that you're going through and reading it. It's worth a huge amount of points. It's really going to be a game changer. Very similar to that 5.8 yard project, which you might want to go back and look at that file occasionally, because how we document it in your notebook is going to be very similar. So if you wanted to find that 5.8 document, I went to Unit 5, and here it is where I blacked it out. We're going to be doing very similar process where you're going to start with make sure you update your table of contents. So make sure you do that. And then when you get into the project, we're going to define the project. We're going to have the project constraints. So it's basically going to be the design brief. You're going to do some research, go through. You're going to have other constraints, do some research. So it's going to be a very similar project. We're going to generate some concepts, brainstorm some ideas. You are going to use a decision matrix in this case. So make sure that you're aware of that. But this could be a really useful document for you to refer back to every once in a while, just to make sure that you understand what we're doing. So the next thing in the folder is to just go through 3 different documents. Those 3 different documents are the actual, what is the virtual challenge. Second one, the design briefs you can choose from, and the third one is going to be the rubric for how you get your points. So for example, some of the things that I just mentioned, this is just your engineering notebook in general. Eventually, when we're done with this project, if there's time, we might run out of time this year, just because of the fact that we're only meeting for half of the classes, and we're trying to give you about an hour of work to do a day. We might run out of time. So we'll do the best we can to get through this. This is the last project of the year. So if we finish, you're going to have a Google slide presentation that is basically going to document all of the things that are in this rubric. Have a picture of your table of contents on a Google slide, the titles on each page of your engineering notebook. So these are things that I'm going to be able to see when I look at the document. The Google slide presentation, did you sign the bottom of every page? Are you dating every page? Is the content in your engineering notebook orderly? Are you using it every day we're supposed to be? I'm going to look for an entry every day. You don't know what group norms are or what the Gantt chart is. I'm going to explain that in this video. So what you're going to do once you decide on a design brief, you're going to basically copy that design brief into your engineering notebook, and when you have that there, you're going to have all these points for this right here, because the design brief you have has the criteria and the constraints and all that kind of stuff. So you would have all of this documented. Once you know what your design brief is, you're going to have to brainstorm some ideas, complete some research about what you think the best idea is going to be to complete your project, and that's where you're going to use the decision matrix. So when you're using the decision matrix, you're going to go through and with your brainstormed ideas and the constraints and criteria across the top, right? So all that stuff is in here. You know, the items listed on the left are your brainstormed ideas, the constraints and criteria at the top of the matrix. Once you have all that stuff, make a decision. What's going to be the best thing to do? Once you have that project, do a rough sketch, get a more realistic rough sketch. The second sketch should have some dimensions to it, and then you are going to start doing some CAD work. So every part that would be required for you to fulfill the project, different projects are going to have different numbers of parts. You're going to have to abide by these criteria. You're going to put each part onto a drawing sheet. Each part should have a proper front. Each part should have dimensions. It should be a multi-view with isometric. Same thing that we've done. Every sheet that we've done, you can snip the eye properties and put them in there. If your final project's wood, make sure you're selecting the appropriate material. If your final project's metal, make sure you're selecting the appropriate material. That way the eye properties are getting updated properly with density and volume and mass. One of the pages is going to be an exploded view with parts list. and general tolerances. Eventually, you need to make sure that you document whether your final project passes the test. Like, did it meet all the criteria, or did you fail? And if you failed on meeting any of the criteria, how are you revising your project? How are you going back and doing that? So there should be some evidence of that kind of documentation. Eventually, you're going to present the solution, and this is the final presentation. So you're going to make this Google slide presentation where you're going to have a title page, the problems explained, the design brief is in there, the constraints are reviewed. If you put the design brief in there, you're going to have that. The initial sketches are going to be in there. The decision matrix was shown and explained for how you made a decision on what you're going to go with. The CAD work, all the parts pages are going to be snipped and put into this Google presentation. Here's a good one. There are cost constraints for most of the projects. That might be something that your design fails that you have to go back to later and redo. You might have to find a way to make your product less expensive. Yeah, just kind of go through. If we were together in class, obviously some of these are going to have to be edited. I made this document to be used for years down the road. So we're not going to present them to the class. So some of these points are going to be deleted for when I'm grading your project. But that's the overall project rubric and kind of where you're going to get your points from. You can look at this in more detail on your own time. So I want to go over here to introduce you to the actual project itself. You are going to be working with a teammate on this. So if you click this link, it's going to jump you down to what it means to work as a team. There's some stuff about effective teams here. This is also going to be presented to you in a PowerPoint at a later time. Actually, I think it's the next day of class. So go through and take a look at this at your own convenience. That's something that you can do today. All you'd have to do is scroll down, or you can click the link. Here are the projects you can choose from. You're going to make a table, a speaker support system, a display case, a Happy Toy meal, a wooden mechanical toy, probably similar to the Automoblocks, maybe, or a locker organizer. And actually, for class on the next day, this is kind of your assignment, is to kind of figure out what are you going to be doing. We're going to divide this document up into steps. So the next day of class, because right now I'm looking at the calendar, and the calendar is going to change. I just brainstormed some ideas on the calendar for how this is going to map out. But the next day of the calendar is here, and this is where you're going to do your group norms and pick your project. And then this is going to be where you do some of your initial research for that project, like you're going to have to go out on the internet and brainstorm ideas and use your decision matrix. So these kind of blend together in the directions. There's not a good way to do it in separate days like this. So basically, your homework for next week is going to be getting through these problems right here. You're going to do number 3, number 4, and number 5. So by the time you get to number 5 is where you're going to have your actual rough sketches done, and you're going to be moving forward. Okay, this is where you're going to develop your group norms, define your problem. In other words, take your design brief and put it into your engineering notebook. Brainstorm ideas. Use the decision matrix to help you figure out which idea is going to be the best. And then that's when you start developing a solution. So you'll have your rough sketches, and you'll begin your inventor work in here around number 5. Some information about how you're going to do your inventor work is here. You're going to have to make a new project folder. Every week, we're going to evaluate our teammates. It's worth 20 points each week. So you're going to give your teammate a self-evaluation. Suppose it's not a self-evaluation, but you're going to give yourself a self-evaluation and your teammate an evaluation. So 20 points every week is based on how you're working together. It's going to end up being like 60 points. So make sure you're completing your evaluations on time. It's going to be part of your daily assignments on those days. Anything that you have to have drawn should be a proper drawing. So any part that you're doing in Inventor should be a proper part. It should have the 3 multi-view and an isometric, dimensioned properly according to the dimensioning standards that we've explained in class. When you make an assembly, you're going to have one page that's an assembly, or you could do several sub-assemblies if you want. But when you do those assemblies, there is going to be an exploded view with the balloon and parts list. Okay. You can document your construct and test a prototype the same way we did it with the yard project. So in other words, if you see what I'm doing, I'm just kind of working straight through this. So defining the problem is your design brief. Generating concepts is brainstorming ideas and using a decision matrix. Developing the solution is your inventor work and your rough sketches. Constructing a prototype is also going to be kind of your inventor work, but also where you're going to do your cost of materials and look at your iProperties. And then you're going to evaluate the solution. Did your solution pass all the tests? So if it didn't, you're going to have to go back and redesign some things, and you're going to document that process. And then eventually at the conclusion, you're going to take all of the work, all of your parts, and basically you're just going to take a bunch of pictures or snips, and you're going to put them into a Google slide presentation, and hopefully that's what I get to be able to grade, and it should be awesome. So I want to show you what those projects are in a little bit more detail. Here's one of them. It's coffee shop, and what's happening in the coffee shop is they're running out of seating. Okay, they have like a lounge chair / coffee or a couch scenario, and too many people are coming into the coffee shop. They don't have enough seats for the people, so they want to redesign their seating area so that they can get more seats in there than what they currently have. So you can read the constraints. Here's the amount of room that you have to work with. So they already have, you can't change any of this stuff over here. This is the amount of room. So whatever you design would have to fit into this area. It doesn't, you could have multiple tables, but it's up to you to brainstorm ideas and come up with things. That's one thing that you could do. Number 2, the speaker system. There's a teacher that doesn't have enough space in their classroom, and they want to design a speaker system that would allow the speakers to be mounted to the walls. Here's the constraints. You're just going to make up some type of system. Again, make sure that everything passes the constraints. This is where your weight issue could come in. You got to make sure that the speaker can sit on it or be adjusted to it somehow. There you go. If I move forward, this is the goblet case. So this one took me a second to kind of get what it was all about, but basically you have this goblet, and the goblet's going to fit inside the case, but the case itself is actually going to be 2 parts. The case, when you open it, is also the display case. Okay, so when you ship something, it doesn't have a good way to view it. So the existing display case is not only going to be the shipping container, but it's also going to be the display case. So figure out how you would do that. Okay. Here's the constraints for the project. You can read that. And I will move forward. Virtua McDonald's wants you to do a kid's toy. The film of the toy should be made for is Roly Poly Oly, the great defender of fun. Kind of sounds fun. I mean, but anyhow, you should have at least 5 parts. Again, you can read the dimensions, and you can read the constraints. There's no pictures or anything to go along with that one. Wooden toy. I think you have the most freedom in this one. It's pretty much anything. It's a little toy that's assembled with either glue or rubber bands, basically like a model kit. It can be anything: a car, a boat, an airplane, a house, a dog, a yard animal. No, just kidding. Don't do that again. It can be anything. So make sure you read the constraints and follow through with that. And then finally, Project 6 is your locker. So a locker organizer. So in some way, shape, or form, it's going to be a locker organizer that fits inside of a locker. Typical locker, typical size. You might need to do some research for what that is. You guys have seen locker kind of assemblies before. So that kind of covers the introduction of this project for you in that 15-minute video, and that's what we're doing today, is we're just introducing it. You don't have any other work to submit other than watching this video. The next day of class, you should have your partner. You're going to do your group norms, and you're going to pick your project, like which one you're actually going to do. Start doing some research about your decisions, and then it's going to be some inventor work time. And I'm giving you, a couple hours to work in Inventor here. If you finish that, you can put together your final presentation, and essentially at that point you're done with the course. There's no final exam. Project Lead the Way is not doing a final assessment in any of its classes this year. If you want credit for this course, we can talk about how you can get that credit. If you're interested in getting college credit for this course, you could email me and I can let you know what some options are to get that credit.